Let's pull back the curtain on Kubernetes. It often feels like pure magic, right? But behind every one of those simple commands is this incredible orchestrated dance of components. So today, we're going to trace the journey of a single command to see how it all really works.
I mean, think about it. You type one command to deploy your app, you hit enter, and a few moments later, boom, it's live, it's scaled, and it's running. But what is actually happening in those few moments? What is going on inside that black box we call a cluster? Well, that's the mystery we are solving today.
And this is our hero for today's journey. It's a simple, super common command, kubectl apply. All we're doing is telling Kubernetes, hey, I want you to create something, and everything you need to know is in this YAML file. In this case, it's a deployment for an Nginx web server. This one little line of text is the domino that starts a fascinating chain reaction. Now, to really wrap our heads around this, let's use an analogy. The best way to think of a Kubernetes cluster is like a massive, super high-end restaurant kitchen. It's a system that's built from the ground up for efficiency, for reliability, and for scale. And just like any great kitchen, it's got two very distinct parts. You've got the brains of the operation, and then you've got the brawn that does all the heavy lifting.
So here's that division of labor, laid out nice and simple. On one side, you've got the control plane. This is our head chef's station, where all the thinking, the planning, and the decision-making happens. And on the other side, you've got the worker nodes. These are your cooking stations. They don't make decisions, they just execute the orders they're given, and they do it with absolute precision. So what holds this entire kitchen together? Well, it's the order ticket system. In Kubernetes, that's a component called etcd. You can think of it as a super reliable database that acts as the single source of truth for the entire cluster. Every request, every change, the status of every single pod, it's all recorded in etcd. And here's the key. If it's not in etcd, as far as Kubernetes is concerned, it just doesn't exist.
All right, so our kitchen is all set up. Let's follow our order, that kubectl apply command, as it actually enters the system and gets turned into a running application. So the second you hit enter, your command goes straight to the API server. The API server is kind of like the restaurant's maitre d'. It's the front door for absolutely everything. It doesn't just let anyone in, though. First, it authenticates you to figure out who you are. Then it checks your authorization to see what you're allowed to do. And finally, a set of admission controllers check if your request even makes sense. It's a whole three-step security check before your order even makes it into the kitchen.
Okay, and this right here is the first really crucial action. Assuming you passed all those security checks, the API server doesn't actually do anything with your request just yet. Nope. It simply writes your intent, what you want the cluster to look like, into ECD. You've officially placed your order. It's now on the ticket system, recorded for everyone to see as the desired state. Now, who's watching that ticket system? That would be the controller manager, or head chef. This thing is really a collection of controllers, and each one is constantly watching etcd for any changes. Its entire job, its whole reason for being, is to look at the desired state you just wrote and compare it to the current state of the cluster. And if they don't match, it springs into action. So in our case, the deployment controller sees a new desired state pop up. I want an Nginx deployment with 3 replicas. It looks at the cluster and sees the current state is, well, 0. So the controller acts, but it doesn't create the pods directly. Instead, it creates another object called a ReplicaSet. This is like putting another, more specific order on the ticket system that says, hey, make sure 3 pods that look like this are always running. So now there's an order in etcd for 3 pods, but they don't have a home yet. They're just sitting there in a pending state. This is where the scheduler comes in. The scheduler is like the kitchen's expediter. That person who looks at an order for a steak and decides which cooking station is best equipped to handle it right now. And the scheduler's decision is this really clever 2-phase process. First up is filtering. It looks at all the worker nodes and immediately gets rid of any that can't possibly run the pod. Maybe they don't have enough CPU or memory, for example. Then comes scoring. Out of all the nodes that are left, it ranks them. Which one is the least busy? Which one is going to give this pod the best performance? The node with the highest score wins, and the scheduler officially assigns the pod to it. Okay, so all the big decisions have been made by the control plane, by the brains of the operation. Now it's time for the brawn, the worker node, to execute that plan and actually bring our application to life. On every single worker node, there's a critical little agent running called the kubelet. This is our line cook. And the kubelet's job is actually pretty simple. It just watches the API server for any pods that have been assigned to its node. The moment it sees one, it gets to work. And this is where the YAML file finally becomes reality. The kubelet reads the pod's recipe. It then tells the container runtime. You can think of this as the oven, like Docker or Containerd. Hey, go pull the NGX 1.21 image. The runtime grabs the image, creates the container, sets up all its networking and storage, and starts it up. And as soon as it's up, the kubelet reports back to the control plane, updating the current state in etcd to running. And just like that, our application is alive.
So our 3 Nginx containers are now running happily across the cluster. Awesome. But, just having them running isn't quite enough. How does anyone actually talk to them? How do we create a single stable address for an application that's made up of multiple constantly changing parts? Well, this is the job of something called Kube-Proxy. Think of it as the restaurant's waitstaff. Kube-Proxy runs on every single node, and it's constantly watching the API server for info about services. Its entire job is to make sure that traffic gets from the customer to the right dish, no matter which station in the kitchen actually cooked it.
So what Kube-Proxy does is it translates that abstract idea of a service into real, concrete networking rules on each node. This means that when a request comes in for our NGX service, these rules just kick in, automatically load balancing the request and sending it to one of our 3 healthy NGINX pods. The person making the request never has to know or care which specific pod on which specific node actually handles it. It just works.
So let's bring it all home. We followed our single command all the way from our terminal through the control plane's decision makers and down to a worker node where it finally came to life. But this whole journey was driven by one single powerful idea: desired state reconciliation. You don't tell Kubernetes how to do things, you just tell it what you want the end result to be. The entire system then works in this constant loop to make reality match your request.
And that really brings us to the final thought here. This isn't just about running an application, because that reconciliation loop I mentioned, it never, ever stops. If a pod crashes, the controller manager sees the state has changed and instantly creates a new one. If a whole node goes down, the scheduler finds new homes for its pods. You haven't just deployed an app, you've described a self-healing system. So the real question is, when your infrastructure can automatically fix itself, what bigger, more interesting problems does that free you up to solve?